Hi there, this is some more GCSE physics question practice. So this one's the acceleration equation. So I'll just recap that equation really quickly. So the equation, you might have seen it as acceleration is the change in velocity divided by the change in time. That could be written as acceleration is change in velocity will be the final velocity, subtract the initial velocity divided by time. Or you may have seen it as the final velocity is the initial velocity plus acceleration times time. You could use either of these, it's completely up to you. Or you could use both or all three. The one that I typically would use for if the question's a little bit more complex would be the bottom one, this one here. And I'll just go through the units. So V would be final velocity is in meters per second. U being the initial or starting velocity is also in meters per second. Acceleration, remember, is meters per second squared. And time is in seconds. Okay, so hopefully that's okay. So what I'll do now is rub that out. I want you to do those three questions and then I'll take you through the answers, and then I've got two more questions for you to do afterwards. So if you want to do these three, remember to show you working out and then press play and I'll take you through the answers. So the first one. So we've got a small plane accelerates at, so we've got the acceleration 0.088 meters per second squared. We've got time and we've got a final velocity of 99.5 meters per second, and we want the initial velocity. So what I would do on this one is write V equals U plus AT, and we want the initial velocity, which is U. So we need to rearrange to make U the subject. So we need to get rid of the plus AT. So the way to get plus AT to the other side is to do the opposite, and then the opposite of adding AT is minus AT. So the initial speed will be equal to V minus AT. Then we just need to put the numbers in. So initial velocity is the final velocity, which is 99.5, minus acceleration times time. So that'd be 0.088 multiplied by 9.09. And if you put that in your calculator, you'll get an initial velocity of 98.7 meters per second. Right, number two. So we've got a train travelling at 63.5 meters per second, and it accelerates at 3.74 meters per second squared for 5.94 seconds. What is the final velocity of the train? So on this one, we just need to use V equals U plus A2. We don't need to rearrange it, so we just need to put the numbers in. So the initial velocity is 63.5 plus the acceleration times time. So 3.74 times 5.94. Could bracket that if you wish. Calculate that, which gives us 85.7 meters per second. Okay, next one. A bus initially travelling at 5.7 meters per second accelerates at minus 0.125 meters per second squared and reaches a final velocity of 3 meters per second. How long was the train accelerating for? So we need to be careful with this one because that acceleration is negative, so it's actually a deceleration. So V equals U plus A2. And what we need to do is to rearrange to make T or time the subject. So let's get rid of the add U. So the opposite of adding U is subtracting U. So V minus U will be AT. And then we simply need to get rid of the multiplied by acceleration. And the opposite of multiplying by acceleration is dividing by acceleration. So V minus U over A would give us the time. So final velocity V, which is 3 meters per second, minus the initial, which is 5.7, divided by, and then the acceleration is minus 0.125. And if you put that in your calculator, it'll give us the time, which is 21.6 seconds. Right, I've got two more questions for you to do. So if you feel that you can have a go at these two, feel free to pause and have a go at them. And then I'll take you through the answers. So we've got to be really careful on this one because we've got we've got the initial velocity, we've got the final velocity, and we've got the change in time. So typically you would do acceleration is change in velocity divided by change in time to give you the acceleration. However, we've got an issue, and that's that these velocities have been given in kilometers per hour, which can happen in your exams. So what I'm going to do is to show you how to convert that. So 71.4 kilometers per hour, so 71.4 kilometers per hour, if we draw it like that, then we just need to turn it into meters per second. So that'd be 71.4 kilometers. So we need how many meters are in a kilometer? So we need to times by 1,000. Okay. Then we need to divide by the amount of seconds in 1 hour. So there's 60 seconds in a minute and then 60 minutes in 1 hour. So 60 times 60, which is 3,600, is how many seconds are in an hour. So now if you calculate that, that will tell you what 74.1 kilometers per hour is in meters per second. In future, if you just want a quick way to do it, to convert, so you might want to make a note on this, to convert from kilometers per hour to meters per second, you just divide by 3.6. Okay, so make sure you've got that down. And that's what I'll do in future, well, for these two questions. All right, so I'm going to get rid of this. If you miss anything, just rewind. Right, so let's convert these. So 74.1, just divide it by 3.6. And then the 65.7, just divide that by 3.6. And they will give us, so the first one's 20.58 meters per second. And the second one is 18.25 meters per second. Okay, so now this is really easy. We just need to do the change in velocity divided by the change in time. So we need to do 20.58 subtract 18.25, or actually the other way around, because it's v change in velocity is v minus u over t. So 18.25, which is the final velocity, subtract the 20.58, divided by the change in time of 4.79 seconds. So if you calculate that, that'll give you an acceleration which is equal to minus 0.49 meters per second squared. So the negative for negative acceleration just means it's decelerating or slowing down. So hopefully that one went okay. If you got that one wrong, you might want to, pause and redo number 5 now that you know how to do the conversions. If not, I'm going to go through that answer now. So a girl running at 15 kilometers per hour accelerates at 0.77 meters per second squared for 3.89 seconds. What is the final velocity of the girl? So for this one, we're going to do v equals u plus a2. So we've got the initial speed, 15 kilometers per hour. We've got the acceleration and we've got the time. We simply need to convert the 15 kilometers per hour into meters per second. So to do that, remember, we just divide by 3.6, which is 4.16 meters per second. And then just put them numbers into the calculation. So initial speed, or initial velocity, 4.16 plus acceleration, 0.77, times the time, 3.89. Put that in your calculator. And that gives us 7.2 meters per second. So hopefully you found that helpful. Thanks for watching, and I'll see you at the next one.